Hello, dear students. Today we are going to see a very important topic in discrete mathematics, that is relations. So before moving on to the concept of relations, we need to know certain prerequisite. So that is nothing but the concept of Cartesian product. So consider any two arbitrary sets A and B, then the set of all ordered pairs A, comma B, wherein A is an element of the set A and B is an element of set B is called as the Cartesian product of the set A and B. So the denotion of this Cartesian product is nothing but a cross between these two sets, and it is also read as A cross B. So the elements in A cross B are nothing but the tuples A comma B, wherein A will be from the set A and B will be from set B. So let us take an example to understand this concept clearly. So here you have been given two sets A and B, where the set has two elements 1, 2, and set B has three elements A, B, C. So we need to find the cross product of the set AB. So how do I find that cross product? So what I'll do, I'll take an element from set A and pair it with each and every other element in set B. So as you can see, first I took the element 1 and paired it with A. Then again I took 1 and paired it with the second element in B. Again I took 1 and paired it with the third element C. I do it the same way for the second element in A. The second element is 2, which I paired with again A. 2 is again paired with B, and hence again 2 is paired with the element C. So in this way, you find the final cross product of set A and set B. So as you can see on the slide, this is your final A cross B. These are few more examples of cross product on the same two sets. If you see very clearly, it is given the set A cross B and set B cross A. Both are not same. Okay. Also, we can find the cross product of a set with itself. That is given in the third part. Now, moving on to the relations, consider this table as on the slide. Observe this table and try to see if there is a relation between the first column and the second column. As you might have guessed, of course, there is a relation between the first column in table T and the second column. It is nothing but the countries and their capitals. So how do you mathematically represent this table? If I consider a set A, which is having all countries in the world, it will be a very large set. Similarly, if I consider B as a set of all the cities that are there in the world, then the first column will be a subset of the set A, and the second column will be a subset of the set B. So how do I define the entire table based on this data? The entire table will be defined as a subset of A cross B. A cross B will be the set having all the ordered tuples of countries and capitals. So each tuple in A cross B will be a country and its capital. So it will be a very vast set. My table T will be a small portion of this A cross B. So in similar terms, I can define a relation. A relation is nothing but a subset of the Cartesian product of the sets into consideration. Binary relations are nothing but relations defined on two sets. So if I consider two sets, A and B, they may be same, they can be different. Then a subset of their cross product is nothing but a relation. So these are the notations of relations. So here in a relation, if an element A is related to B, then I can write A R B. Similarly, if an element A is not related to B, related in the sense if there is not a pair A comma B, then I can write A cross R B. Fine. Then let us see an example of a relation. So consider a set A having four elements 1, 2, 3, and 4, and the relation R on that set is defined as A divides B, then that particular tuple is present in the relation. So as you can see, the relation R has all these tuples. So which tuples should be included in the relation? The tuples that satisfy the previous condition. Which condition? The condition in which A divides B. That means the first number in the tuple should be able to completely divide the second element in the tuple. So if you see the example 1 comma 1, 1 is able to completely divide 1. Similarly, there is a tuple 2 comma 2. So which is the same. 2 is able to completely divide 2. Similarly, 2 comma 4. 2 is able to completely divide 4. So all the numbers, all the pairs that satisfy these property, they are included in my relation R. Now, list the ordered pairs in the relation R from A 0, 1, 2, 3, 4 to B 0, 1, 2, 3, where the following properties are satisfied. So take a moment and try to solve these questions before moving on to the solution. So this is the solution for the previous question. So in the first relation, the tuples that satisfy the property A equal to B, only those tuples are included in the relation R1. So if you see in R1, 0, 0 is a tuple. Why? Because 0 is equal to 0. The first element will be from set A, second element is from set B. In the second example, A plus B equal to 4. That means A and B should add up to 4. So as you can see, 1, 3, 2, 2, 3, 1, and 4, 0 are the tuples. So if you look closely, 1, 3 and 3, 1 are present in relation R2. Why? Because 1 and 3 are present in both the sets. But 4, 0 is there. However, the tuple 0, 4 is not present. Why? Because as 0 is present in the set A, but set B does not have the element 4. Similarly, the third question, A greater than B. So all the tuples in which the element A is greater than B, those tuples are present in the relation R3. So I hope you all understood the concept of relations. Thank you.